students, welcome to this lecture number 5 in the chemical equilibrium chapter. In this lecture we are going to discuss the equilibrium constant for the heterogeneous reactions. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. So today's video, heading of this video is heterogeneous equilibrium. First, let us understand what do we mean by the heterogeneous equilibrium. Heterogeneous equilibrium is such equilibrium where in the system current more than one phase. It is not in the same phase but more than one phase. In homogeneous equilibrium, what we understand, there is in the previous video we have discussed in detail, there is the one phase that is between the electant, reactant and the product. But in the heterogeneous reaction, it is more than one phase. The common example of this heterogeneous reaction equilibrium is the water vapor equilibrium in a closed container, closed vessel. In that closed vessel, when the water evaporates into a vapor phase, there is a two phase we can observe, that is vapor phase, the water molecule in the vapor phase and as well as in the liquid phase. So there is more than one phase. So we call it is a heterogeneous reactions, heterogeneous equilibrium. So these reactions for the heterogeneous equilibrium between the water vapor, between the liquid water and the vapor, water vapor, is the heterogeneous example of the heterogeneous reactions. And similarly, another thing, that is the solid, any solid, that is, as for example, you are taking the calcium hydroxide as a solid, it is in equilibrium with its saturated solutions. Saturated solutions, here that it is ionizes, and you can see it is having this equilibrium. These are in aqueous medium and this is in aqueous medium. So here you can observe that it is in the solid state and here it is in the saturated solution state. So there is a two phase, more than one phase. So we can say it is a heterogeneous equilibrium. So this is one of the examples and this is one of the examples. Now we want to understand how do we write the constant, equilibrium constant for these heterogeneous reactions. Heterogeneous reaction, that you can understand that it will have, obviously, one phase will the solid phase and other phase will be the liquid phase, and the molar concentration of this liquid and the solid phase having a constant value. It will not going to change because it is independent of the amount present in it. So we can simplify the equilibrium constant, equilibrium expression for the heterogeneous equilibrium. Suppose there is a substance. Suppose this is a X is a substance. So this substance, when in the concentration of this molar concentration of this substance in the solid state, or this substance having the liquid state, this substance, the molar concentration of this substance in the liquid state will be constant. This will be the constant one. And we have to put this in the square bracket because we are expressing the molar concentration. Now, if this substance in the gas phase, if it is a gas phase, then is molar concentration, and it is in the aqueous phase, its molar concentration will be different. So this is a constant. The molar concentration of the pure liquid and pure solid is constant, whereas this concentration varies. So when this will be constant, then we have to take it as a 1. Suppose we are taking an example of a very important heterogeneous equilibrium reactions, that is the decomposition of calcium carbonate. The calcium carbonate is decomposes and it produces calcium carbonate in the solid state. This is in the solid state, and when it is decomposes, that is a thermal decomposition, it will going to produce calcium oxide in the solid state and the carbon dioxide in the gaseous state. So you can see this is also an example of the heterogeneous equilibrium. Here this is solid state, calcium oxide in solid state and carbon dioxide in the gaseous state. So, and this equation has been carried out in a closed vessel. So what is happened? When this is in the equilibrium state, we will say that calcium carbonate solid, calcium oxide solid, that is in equilibrium with this CO2 gas, and the CO2 gas having a constant pressure. Now we can write this equilibrium constant for this heterogeneous reaction is like this. That is the molar concentration of calcium oxide in the solid, and this is light in the solid. This is the solid, and here this is the gas state, and in the denominator you will have this calcium carbonate solid. See, these two things, that is, you already understand that the molar concentration of this solid, pure solid, will have the constant value. So we can omit this, we can simplify this equilibrium expression into this CO2 gas, concentration of the CO2 gas. This will be a simplified equilibrium expression for this heterogeneous equilibrium. But this is when it is in a Kp, so we see that is a partial pressure of carbon dioxide. So at the equilibrium, what is going to happen? The carbon dioxide gas having the constant pressure will be in equilibrium with the solid calcium carbonate and the solid calcium oxides. So this is the equilibrium state. Now it has been observed at the temperature of 1100 Kelvin. There is a pressure of the gas, pressure of the carbon dioxide gas is pressure of CO2 gas is normally it is found 10 to the power 2 into 10 to the power 5 Pascal. Now what will be its equilibrium constant in terms of partial pressure? That will be 2, because we have to express this Pascal into the bar unit. We know 1 bar is equal to 10 to the power 5 Pascal. So we will divide this and it will give the equilibrium constant 2. So this is the heterogeneous equilibrium constant. This is the question in the preparation of calcium oxide from the calcium carbonate using the equilibrium. This is the equilibrium given, and Kp is expressed in this form. the temperature in Celsius to which the vessel must be heated so that the pressure of the carbon dioxide is 1 atmosphere at equilibrium. That you have to calculate. In which pressure, in which this is 1 atmosphere carbon pressure of the carbon dioxide is given 1 atmosphere at the equilibrium, and which temperature this pressure will be there. That you have to calculate. You have to be given this relationship. So what will be there? We have to first understand the Kp. From this numerical, you have to understand the Kp, because we know when we make the equilibrium expression, what we found? The Kp will be the pressure of the gas. The pressure of the gas is 1 atmosphere. So we can say here Kp is 1 atmosphere. So we will just put this value in the Kp. So log 1 is equal to 7.282 minus 8500 by 7 by T. And this T you have to calculate. Log 1 we know it is 0. Log 1 0, then this equation is come like this. And T value, you have found the T value, and from this you have to subtract the 273, then we will found this will be the answer. So this type of question will come that you can easily, if you know the concept, then you can easily able to find out the solution. So what is here now? You have to know the partial pressure in the heterogeneous reaction. The partial pressure is basically the Kp of this reaction. Equilibrium constant of this reaction, that is here is 1 atmosphere pressure, so it will be 1. So in this fashion we will able to calculate this. First we have to calculate T, and from this we will calculate T, because you have to answer it in Celsius, so you have to subtract it by 273. Okay. This is again a question before you. The question number 2, for the reaction, this is the reaction, and you can see this here, that which of the following is correct. You have given the different equilibrium expressions, equilibrium constant, that you have to see which will be correct. This is a heterogeneous equilibrium, and you have to see which is the correct. See, for this heterogeneous equilibrium, we can write Kp for this, the partial pressure of this and partial pressure of this solid do not have sense. So its Kp we can write the partial pressure of H2, that is P over whole square. Okay. Then Kc, when we write the Kc, then also this is the molar concentration of the solid phase will be constant. Then we can write this will be H2 the whole square. Right? Now in terms of Kp, we know this relationship. By this relationship, that's RT divided by, in the previous lecture we have understood that this is the molar, this RT is basically the total mole as the product minus total mole as the reactant. So here 2 minus 0, there is no gaseous, only solid, so this 2 minus 0, and it is will be Kc is equal to RT is equal to 2. So all the expressions are correct for this heterogeneous equilibrium. So we can write this D is the correct choice. D is the correct answer. Okay. Calculate the partial pressure of carbon monoxide from the following data. Here has been given first the thermal decomposition of the calcium carbonate, and you will find this calcium oxide and carbon dioxide gas. Its constant, equilibrium constant is this, and the second equation is this. Here you can see this is also a heterogeneous reaction, heterogeneous equilibrium. You can see its Kp is given here. You have to calculate the partial pressure of the carbon monoxide from these equations. So from this equation you can understand that Kp is basically the partial pressure of carbon dioxide. So we can write this Kp is given. So partial pressure of the carbon dioxide will be 10 to the minus 2. Okay. Now from this reaction you will again understand that is Kp is equal to the partial pressure of carbon monoxide, it is a whole square, divided by the carbon of the solid, pure solid state, so we will not take into account, and this is given the partial pressure of carbon dioxide. So now we are going to put this value. We have to calculate this partial pressure of carbon monoxide. So Kp is given 2 and this is 10 to the power square. So what we will get? You will get this 16 into 10 to the power minus 2. So PCO. So we can calculate here PCO is equal to, it will be coming around 0.4. So this will be the answer. So this type of question will come in your exam, competitive exam, IIT JEE. In the board exam also you will face this type of questions from the heterogeneous constant, heterogeneous equilibrium. And so that is all for today's video. Today's lecture we will discuss the more topic in the next video. Thank you very much for watching.